If you recall that once we had our equation for the ellipse, we realized that there are actually two different kinds of orientations for the ellipse, or at least the ones that we care about, namely that of a horizontal and that of a vertical ellipse, where the major axis is horizontal or vertical. So technically we kind of distilled it down to four different equations for an ellipse, depending on whether it's horizontal or vertical. For the parabola, however, since it is an open curve, there are, technically speaking, four different orientations. We're already familiar with the first two, and so we'll treat those first. But then we're going to look at two other orientations that I don't think we've experimented with yet, but you're going to see that it makes a whole lot of sense. So the very first one, right up here, is the standard y is equal to ax squared, where a is a positive number, a number greater than 0. If that's the case, it's going to open up. That's what we've seen so far. And p, the distance from the vertex to the focus, is going to be 1/4 times the reciprocal of a. And then if we want to find the directrix, once we find our distance p, we're going to see that y is going to equal just negative p. If we look at our picture, this all makes sense. If our parabola is opening up, the focus point is going to be on the y-axis, so the x-coordinate will be 0, and the y-coordinate is going to be p units. Meanwhile, the directrix is going to be down below the parabola, and it's going to be a horizontal line, so the equation for that line is just going to be y equals something, but it's going to have to be y equals some negative number, specifically negative p, right? Everything is dependent on that distance, that focal distance. All right, so hopefully that makes sense. If we flip things around and take a look at the second example, y is equal to negative ax squared, right? When a is negative, our parabola is going to be opening down, right? If it's opening down, then it stands to reason that the focus point, the x-coordinate is still going to be 0, but the y-coordinate is going to be a negative number. So p is going to be negative if the parabola is opening down. So you can kind of see if a is negative 1/4 times the reciprocal of 1 over negative a, this will always be a negative number. Always, 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 if a is negative. So this p down here for the focus point is going to be a negative number. Meanwhile, the directrix, which is going to be now above the parabola, is going to be at y equals positive p. Excuse me. All right, so hopefully that all makes sense. One thing that I don't remember if we've done this in class yet, excuse me, is what if we were to switch things around, and instead of squaring x, we squared y instead. If we do that, like we have up here, y or x is equal to ay squared, where a is a positive number, we're going to get a parabola that opens up to the right. If it's opening up to the right, it stands to reason that the focus point, the x-coordinate, is going to be p itself, and the y-coordinate is going to be 0. Meanwhile, the equation for the directrix is going to be x equals negative p. All right, and so that should all make sense. Likewise, if we were to make a negative, it's going to open up to the left. The focus point, the x-coordinate will be negative p, and then 0, and then the equation for the directrix is going to be x equals positive p. All right, so hopefully that all makes sense. These are the only four possibilities for a parabola, possible orientations, at least that we're worried about. I guess in theory you could have one that's kind of cockeyed, that's kind of going diagonally, but we're not going to worry about that for right now. For right now, we're going to keep all the parabolas simple, make their vertex at the origin of 0, 0, and just look whether they look up, down, left, or right. So that being said, we're going to do a couple quick practice problems together so that you can kind of know how to approach different problems. And my first recommended step is that when you come across a problem, look at which one of these four scenarios you're going to be looking at, because then you can expect certain things. If you're come across a parabola that fits this form, where a is negative, you know from the start that the coordinates for the focus point are going to have a negative number, and the equation for the directrix is going to be a positive number, right? Simple things like that to kind of make sure that you're doing things right. All right, so I'm going to have to tweak this just a little bit. There we go. So let's take a look at question number 1. And let's say for question number 1, we have x equals negative 1/6 y squared. And the question is, what are the coordinates, what is the focal distance? Well, actually, let's just change that. What are the coordinates for the focus point, and what is the equation for the directrix for this parabola? All right, so first, which one of these 4 scenarios does this fit? Let's just go ahead and number them. Let's call this 1, 2, 3, and 4. All right, so you can see that since y is squared, it's going to be either 3 or 4. Since a is negative, it's going to fit scenario number 4. So whatever p is, we know that p is going to end up being negative. And so our focus point should have a number that is negative, and the equation for the directrix should be a positive number. All right, so let's just kind of follow the steps. So p is going to be equal to 1/4 times the reciprocal of a. A is negative 1/6. So the reciprocal of 1/6 is just 6, or 6 over 1. It's pretty easy enough. All right, so the 1 times 6 is going to be negative 6. 4 times 1 is going to be 4, and we get negative 3/2. That is our p. So and you'll notice that I'm not graphing anything for this. I'm just using the mathematics that we were able to distill and can derive the coordinates for the focus point and the equation for the directrix just from the information that's given. So if I know p is equal to negative 3/2, which is what was expected, right? We should get a negative number for p. That means that the focus is going to fit this form, namely the y coordinate is going to be 0, and this is going to be our p, negative 3/2. And then for the directrix, the equation is going to be x, and it's going to be the positive version of p. X equals 3/2. All right, so just kind of as a mental check, make sure this makes sense. Since this is negative, this should be opening to the left, which means our focus point should be in the negative region of the coordinate plane, and our directrix should be in the positive portion on the x-axis. And this checks out, so we're good to go. And this is running out of ink, so I'm going to switch colors. All right, for the second one, let's say that we're given p, right? If we know that p is equal to 2, and we're given a brief sketch, so we know that this is opening up, that means it's going to fit the general form of number 1. So at the end of all this, we're going to have something like this, right, where a is positive. Now we know p, but we don't know a. That's easy enough. We can just kind of set up an equation with what we know. So if p is equal to 1/4 times the reciprocal of a, we can just say 2 is equal to 1/4 times the reciprocal of a. And now all we got to do is solve for a, which is going to be 1/4a. Now, I mean, there are a few different ways you can go about this. Firstly, I'm going to multiply both sides by 4. So we're going to get 8 is equal to 1/a. And then if we just take the reciprocal of both sides, we should maintain an equality. So a is equal to 1/8. So if a is equal to 1/8, now I'm ready to write my equation for this parabola with p value of 2. That's opening up. It's going to be y is equal to 1/8 x squared. Easy enough. All right. Now, for number 3, we come across another equation. It's going to be kind of like number 1. What are the coordinates for the focus point, and what is the equation for the directrix? You'll notice that this is not written in standard form yet, so that's going to be kind of our first objective. And this is similar to what we were doing back when we were talking about quadratics, is get y all by itself on one side and everything else on the other side. So it's not very much work. We just have a negative y. But I'm going to flip things around as well to make it look a little bit more comely. So I'm going to multiply both sides by negative 1. We're going to have y is equal to negative 3x squared. So which of the four forms is this going to fall under? Number 2, right? So we should expect that the focus point should have a negative number and that the equation for the directrix should be a positive number. In this case, our A is -3, so if we want to find our P, our focal distance, P is going to equal to 1/4 times the reciprocal of A, which in this case is going to be 1/-3. Okay. Which is going to get us -1/12. Easy enough. So our P is -1/12, which means that the focus point, again, looking at this, our x-coordinate should be 0, and our P should be a negative number. In fact, it is, so -1/12. And for our directrix, the equation is going to be y equals P, the positive version of P, so 1/12. Easy enough, all right? So that wasn't too difficult. All right, take this other one. First thing you're going to do is write it in standard form. Get y all by itself. So I'm going to divide both sides by 8. Y is equal to 1/8 x squared. You'll see that, oh, you know what? This is actually the same problem as number 2. I did not anticipate that. I didn't look carefully at my notes. So we've already done this one. If A is 1/8, we know that if we do the magic math, we're going to get a P of equaling 2. And so our focus point is going to be 0, 2, and our directrix is going to be y is equal to -2. And we're done. Moving on. All right. Again, we do not have this one written in standard form. In this case, y is squared, so we know it's going to be either the third or fourth iteration. So get x all by itself. So I'm going to divide both sides by -16. All right, cool. So my A is -1/16. All right. Since it's negative, I know this is going to be scenario number 4. So let's find P. P is going to be equal to 1/4 times the reciprocal of A. A is -1/16, which means that the reciprocal is going to be -16/1, which is going to get us -16/4 or -4. So P is -4. Which means that the focus point is going to be -4, 0, and the equation for the directrix is going to be x equals 4. Easy. All right. I'll double check, but I'm pretty sure that's a good smattering of the kinds of problems you're going to see for the homework. Basically, everything can be distilled down to these 4 possibilities. And once you know that, you can have a good idea of what to expect. What's the focus going to look like? Which one's going to be a 0? What's it going to be positive or negative, etc. Same thing for the directrix. And yeah, that should be sufficient for the evil of this video.